Hello everyone, welcome to the first webinar this year dedicated for partners, and we are glad to see so many participants here, and this will definitely continue the success of model-based system engineering webinars which we had last year, gathering hundreds of people, and we see that the same attendance level we have also in the partners webinars. Today's topic is dedicated from BCE PLE. Product line engineering meets MBSE, the best of the both worlds. Magic and BigLever joined forces to bring Magic Draw into the PLE ecosystem and support the integration of feature-based PLE and MBSE with Magic Draw, BigLever Software Gears Bridge. This webinar will explore the engineering and business impact and key benefits of combining PLE's innovative feature-based variation management capabilities with powerful visualization, analysis, verification, and validation capabilities of MBSE. And we are glad to have here Dr. Charles Kruger, who is the founder and CEO of BigLever Software, the leading provider of systems and software product line engineering solutions. Dr. Kruger will provide the webinar, and he is the acknowledged thought leader in the PLE field with more than 25 years of experience in software engineering practice and more than 60 articles, columns, book chapters, conference keynotes, and session presentations. Also, he is co-chairing PLE at working group at Incose, and he has a lot of industry experience. And also, we are glad to join him from Magic's side as hosting this webinar, and here we have Andrew Sarmanas, who is product manager, and he will assist with any future related questions, and also we have senior analyst Tomas Juknevičius, who is the project manager for integration between PLE and MBSE. So I'm glad to give my presenter rights to Charles. And hello, Charles. Stage is yours.
Engineering field, as you might expect, it's all about engineering a family of similar related products that have a lot in common, but have variations in their features and functions. So the engineering activity is then a question of how can we use a common set of shared assets to take advantage of what's common, have a managed and well-defined model of a set of features so that we can understand and abstract, reason about, engineer those things that are different, and then have a means of taking advantage of that to have a very efficient production and engineering process to support the engineering of an entire portfolio or a family of similar systems. So, the fundamental goal here is how can you best take advantage of those things that are common across your product family while you're doing the engineering of that family, and then deal with all of that complexity that comes up trying to manage those slight variations that are intermingled throughout the engineering assets that sort of give us all a headache as we're trying to manage that collection of products and those variations among them. So, of course, the model-based engineering field is much more well-known probably than the product line field, and so some simple definitions I found here. Of course, models are meant to provide abstractions for some real-world systems or processes. And for example, at the bottom we talk about model-based systems engineering, where we're looking at models in a very formal way to support the systems engineering lifecycle, requirements designs, testing, those types of things, simulation analysis. And so sort of collectively just referring to the systems and software model-based engineering as model-based engineering as a unified concept there. Just a little background on BigLever. Our role in the community is very focused on product line engineering. That's all we do. That's all we've done for our 15-year history in commercial practice. So we have tools, we have methodology, and we focus on the organizational change that's required as you're adopting product line engineering into an organization. So it's a different way of working, a different way of thinking. It requires more change to the organization and the culture of a company than a lot of other engineering disciplines, and so it requires us to focus on helping companies deal with the organizational change issues in product line engineering. We have a framework that enables us to create ecosystems and partnerships, and so our partnership with No Magic, for example, is our way of bringing Magic Draw Cameo into the ecosystem to make product line engineering work as an extension to those particular tools. And so our framework and our ecosystem is designed to help end organizations be able to use the tools and the assets that they have selected and have been using historically, but to extend those in order to better support product line engineering. So, one of our key, things that's really unique and valuable about our services here at BigLever is that we've got a lot of proven history, written case studies, a lot of information available that helps organizations very quickly learn about how to adopt product line engineering. So you can see an example here of some of the more significant and the more highly published examples in product line engineering that are available. I won't go through this chart in detail, but you can see in the far right-hand column some of the really dramatic engineering benefits that are possible with product line engineering, and ultimately that's the thing that's driving organizations today to make the effort to take the transition into product line engineering. These are benefits in the engineering organization, improvements in productivity, cost savings, overhead, scalability, being able to do a whole lot more deliveries with a whole lot less effort than had been possible before. So these types of things ultimately lead to business benefits. So it's not just improving engineering, it's improving engineering in ways that are large enough that the business can actually take advantage of that to achieve certain competitive benefits, competitive positioning within their market space. So we look and we sort of observe these big benefits that those case studies are showing, and they're big enough to achieve what we call this discontinuous competitive jump as organizations move into product line engineering. And ultimately that's the goal of doing this activity. Let's do things in the engineering organization that really allow us to help our business do better in the markets. So what is it that, what is PLE all about? Let's do a little bit of sort of the theoretical, conceptual underpinnings of that. We like to use an analogy to a factory. The factory in this case is not producing physical artifacts, it's producing the digital assets that we use in the engineering of a particular product family. So you can see here on the left side of our conceptual abstraction about this product line factory, the supply chain that's coming into the factory there in the middle comprises all sorts of artifacts that you find across the systems and software engineering lifecycle. So things like requirements, designs, could be mechanical bill of materials, could be user documentation. All of these things that are produced to support a family or a portfolio of products, we're going to engineer those in a way that enable and support an entire product family to be supported from that collection of assets coming in there on the left. That supports our entire product family. To help drive the automation, we use this abstraction I mentioned earlier, referred to as the features. So there are a lot of definitions of, what's a feature across the engineering field, but in this case it's a very specific definition intended to provide features from a product line perspective. It's those differentiating characteristics that identify those things that are different from product to product in a product family. You can think of it as like the options. When you say go buy a new car, you have a list of options. What features do you want on your vehicle and which features do you not want on your vehicle? So you can think of this, very abstracted view of variants and options that are being offered on a particular product family. And then the second piece of that is for every product that we want to produce in our factory, we go to the feature catalog and we choose, which features do we want on this product, which features are not needed or not desired on this particular product. And so you're stepping through your feature catalog of offered feature options, and you're picking and choosing what's in and what's out for a particular product. So you'll get a collection of this bill of features, one profile or one definition of features for each product that you want to produce in your product family. Then we apply automation, and so the automation will look at that model of the features that we want. It will look at the assets coming in over there from the left, and it will produce the appropriate product asset configuration to support that feature set. So the bill of features comes in the top. That's the request of the product configuration we're interested in. The assets that are created and available to support that come in from the left side of our factory, and then a product comes out that matches our bill of features characterization that then gives us requirements, designs, source code documents, whatever assets are being managed in a product family, those things will come out the right side of our factory. And we can do that, for many, many different configurations of product within a product family. So conceptually, it's just like a factory working on the digital assets that we use in the normal systems and software engineering lifecycle. So this is in contrast to the way historically we've thought about how to build product families in the industry. So historically it's been what we refer to as product-centric. You tend to think of, what do I need to do to deliver each product, and then we coordinate with the other products that are being delivered out of that product family in order to reuse or share or take advantage of things that are common. And so we see a lot of then branching and merging and cloning and owning and copying and talking to people in the hallway in order to get this particular job done. And the reason that this approach has sort of reached its limit of how valuable it is in the industry is ultimately, if you look at a product family within products in it and you do the math on this red line of communication and coordination that's required to do it, those red lines are proportional to n squared. So as you add more and more products to your product family, the complexity of trying to manage things this way grows polynomially. And we know that eventually our engineering capability is going to be overwhelmed by complexity under a polynomial complexity growth curve. So what we're doing with product line engineering is saying, can we come up with a new approach to tackle n squared complexity? And of course the answer to that is our product line engineering, feature-based, factory-based approach to doing this. That will bend our complexity curve flat so that we now have a linear growth in complexity as our product family grows over time. So to look at that then from our factory point of view, what's really changed now when we compare this to the product-centric approach with the various silos and the tangled, intercommunication complexity of all of those red lines. Here is that same set of products on the right, but now being delivered under the product line approach. You'll notice now that our engineering effort is shifted over to the left. We're going to focus on this shared set of assets that support the entire product family. We're going to create a model of the differentiating characteristics. Our feature model is going to drive the process coming in from the top so that we can feed in the various feature profiles to automatically configure and generate the assets that are needed for product A, product B, and product N. So in this more detailed view, what I really want to show you here is, what's the secret to getting those assets to be configurable according to features in this automated approach. And the key then is what we refer to as variation points. Within your assets, you're going to tag and encapsulate parts of those assets that relate to the feature. So if I have an optional feature and that relates back to one or more model elements in a design model, then what I want is to be able to tag those design elements, encapsulate them to say, include this in my model when that feature, a particular feature in my feature profile is requested, but if that feature is not included in a product, then you can leave these model elements out because they're only needed or required when I have a particular feature enabled in my feature profiles. And you can do that to requirements, you can do that to conventional source code, test cases, user documentation. What we do is provide a mechanism from BigLever that allows you to, again, encapsulate and identify parts of the assets that are variants or options, and then relate that back to the features in our feature catalog. So thinking ahead, when we talk about our integration with Magic Draw, what we've done is created through our integration the ability to turn model elements into variation point model elements. These model elements are part of our design model over here on the left, but some pieces and parts of our models are now optional or variant, and those are related back to the BigLever feature model that we use to drive the configuration and the automation. So what this does now is our engineers over there on the left, they can think very broadly across the entire product family. You'll create your designs, your requirements, your assets across the lifecycle according to features, and thinking broadly across the entire product family rather than engineering one product at a time according to the old sort of the siloed view of the world where people were huddled around and focused on individual products. So you can see this gives sort of a horizontal cross-product family view that we look at, and everything inside of this red box that I just drew represents our conceptual PLE factory that's being used to derive and deliver many configurations of our assets as part of the engineering process. We talked about reducing the complexity, the n-squared complexity problem. We can see now how this happens. If I find a defect over in a product that was delivered out of my factory on the right, I ask the question, what is it inside of my factory that caused this defect to show up in a delivered asset coming out of the factory? And so we can find the root cause of that issue over there. We can fix it once inside of the factory, regenerate that product, or maybe the set of products that are impacted by that defect. But now, we find the issue once, we fix it once in the factory, and we're going to regenerate anywhere from 1 to n products and redo the delivery there. But now, because it's at most n products we're delivering, we've reduced our complexity down to order n. We're no longer dealing with this cross-product complexity because everything goes back to the factory as the single source of the truth about where artifacts are created, engineered, defects are fixed, enhancements are made, and so forth. So this is really the key. If we look at what we've done under this approach, we still do all of those things we do in the engineering process. Whatever your organization does, every organization tends to have their own unique layout of the engineering V lifecycle. And people will still do their requirements and their code and their models and bill of materials and their tests and their user documents, their calibration data. Whatever it is that you do today, you'll continue to do that. But now what's happening is that sitting in the center of the V, there's a new model that's being introduced. It's this product line diversity model about features. Everybody, no matter what asset they're building, is looking to that feature model and saying, what are those things I need to support in my particular discipline across the engineering lifecycle? What are the ways that this diversity and variability being modeled in that feature catalog, how does that impact my work? But everybody's looking to that single source of truth about diversity and variability so that there's a very clean transition from stage to stage in the life cycle, and there's no confusion or different representations of diversity and variability across the life cycle to ultimately lead to complexity and errors and mistakes and repetitive effort trying to model product line variability in different tools using different techniques. So now if we take that and say, what does this really look like in operation? What are the new roles, responsibilities that an organization needs to support? The answer to that is sort of shown here. You can see people now spread across the view of the factory. So down in the lower left, we have our engineers, again, working in the same tools and assets they use today, but they're thinking relative to this feature catalog. We have to create this new model in the feature model to represent variability. So that's a new role, responsibility, and an artifact. As we decide which products need to be produced in our product family, either through sort of commercial market studies, or if you're in a business model where you're producing specific products for specific customers, then these would be customer-driven feature choices that are being made for each of the products you deliver. Once this is in place, now you can do the fun part, which is feed these profiles into the automated configurator, and out on the right-hand side comes a filtered set of assets that are filtered according to the features in the bill of features profile. So a couple of questions. Let me look here real quick in my question queue. So one is, will a presentation be available as a PDF? Yes, we can certainly make that available. I'll coordinate with our friends at Magic to figure out how we can get those distributed to you. And the AP 233 standard, I am not familiar with that one, so I actually would not know the answer to that question. So maybe if you can type in a little more detail about what that is, I'll be happy to do that. So there are a few standards for product line engineering and related to model-based engineering that have come online. ISO, for example, has a product line standard, and I'm on that committee that helps devise that standard. So we tend to do whatever we can to adhere to, follow those standards as we go. Okay. So, if we look then across the life cycle, the way that organizations and individuals absolutely need to work under product line engineering is to continue using the tools that they know and love and work with. It would be really bad if we'd say, hey, to do product line engineering, you need to start from scratch, and hey, we're going to give you a whole new set of tools to use. You have to get rid of your old tools and use the new tools. That would be, of course, silly, and nobody would ever do that. So what we do is represented here in this ecosystem. So on the right, we have this product line framework that we provide from BigLever. There's an API that provides access and integration into that gives other tools access to the feature models, the automated configuration capabilities, the ability to create variation points in your assets. And so, for example, in our No Magic integration, then what we do is create a bridge between that tool and the API, and by creating these bridges, that's what adds a tool into the PLE ecosystem that's provided here at BigLever. So there's a long list of partners. We tend to be very customer driven, right? So if we have a customer that wants to do PLE, they'll request integrations that are currently not in our portfolio. We're of course focused today on the No Magic integrations into this ecosystem, but most organizations have a significant collection of tools from a lot of different vendors, and so we try as best as we can to support the needs of our customers. So here, from a magic draw point of view, so you can, however, at whatever level you use magic draw, might be for requirements, system design, model-based software development, model-based testing, however you're applying magic draw, you can, think of how that integrates across the life cycle in order to get your work done. But the bridge and all of this work to support that is in place now with a very nice collaborative effort that we've done with the No Magic organization. So, one of the subtitles I put up when we started here is that product line engineering is really a new dimension in model-based engineering. That's a way of thinking about the relationship between model-based and product line engineering. So I just have a couple of slides here to point out what that really means. How do you think of this new dimension or new facet of model-based engineering? So from a product line point of view, we use this slide to say, in order to have a complete technical solution for product line engineering, you of course need this multi-product dimension, and that's what we've talked about a lot so far today. How do I get product A, product B through product N delivered out of a factory? We've certainly referenced the idea that this is not just for one particular asset type. It needs to support the entire systems engineering B life cycle. And so the issues then in this multidiscipline dimension, relate to traceability and common techniques, the single source of truth about features and how it impacts all of these artifacts. And so how to bring product line engineering into the multiple disciplines is a key part of a solution. And then of course all of this has to evolve over time. So when you do this, you don't end up with a set of shiny reusable assets that sit up on a shelf for months and years on end. Just like today, your engineers come in the morning and they've got a set of enhancement requests and defect reports and everything in the factory, all of our assets, all of our features, all of the traditional activities across the life cycle. All of those are candidate for evolution and change, and these things change at a high rate of speed, just like they do today in an engineering organization. So going from left to right, now we need a very disciplined approach to evolving our supply chain of shared assets in the factories and the feature models so that we can continue producing out of our factory in a very predictable, well-defined, well-controlled evolutionary approach. So how this relates to model-based engineering versus feature models, oftentimes people at first glance will say, well, hey, I can just model features in my UML or my SysML models. Why are you giving me something, additional to work with? Well, the answer to that is sort of reflected in that previous slide. They're really separate concerns. So in your model-based models, you're modeling things about your particular domain, your particular system, your particular family, behaviors, concepts, constructs. The product line feature models are looking across the product family and saying, let's look at those differentiating characteristics. What are those concepts that would cause one product versus another product to be different within my product family? And so it's not now talking about behaviors or concepts in the actual systems that are being delivered. It's in that orthogonal dimension that says, let's talk about the options and the variants and the differentiating characteristics. And so by keeping those concerns separate, it's going to simplify the comprehension, the reasoning, the rationale behind what's in your feature models versus what's in your system and your software design models. And so that's sort of a key piece that we've discovered really helps simplify the overall process. The other thing that sometimes we see is that, well, let's take this feature approach. It's a different type of model. We'll add feature models into our MBE models, and it'll just be more modeling that we do. But what we find is that organizations oftentimes have assets that are not just straight up represented in their models. So user documentation, for example, is a classic example, or requirements documents that may be delivered in a textual form. There may be standards that are required that aren't compatible or consistent with a modeling language or a modeling approach. So most organizations are faced with this issue, and if you sort of encapsulate your feature models and your product line models inside of your MBE models, now you've isolated those other tools that need to be supported, and those can't be supported very effectively then as part of a true PLE model. We need this cross-lifecycle approach, supports all tools, all assets. In some cases, maybe everything is encapsulated in model-based systems and software engineering constructs. Oftentimes, organizations that we're working with today are still not 100% in that world, so we can't treat the model-based constructs as an island where we can also put our feature models as well. Okay, so before we jump into the demo, just want to sort of mention that as well. The tools and the technology we talked about, there's some additional activities that need to be supported. We talked a little earlier about organizational change. You can imagine that moving people under a factory approach will create new roles, new structures, new process, and so there's organizational change that occurs. In order to best support that, we tend to get the business involved in this as well to really connect all of this change with the business objectives and business opportunities. And so we have a methodology that supports not just the technological ideas here, but the organizational, the process, and the business objectives, and getting all of these things connected together. So Sorry, moving ahead here. Again, just to summarize, the idea is we're looking to really significantly improve engineering through this product line engineering approach, high degrees of automation, high degrees of modeling, variance, and options, and going from there. Okay, looking at a couple of other questions then. The step standard. So that one is comes up every now and then. I'll just have to say that we're not deeply involved in that one at the minute, but we'll certainly be looking at that as part of the exchange standards and how this could be supported. You know, we do work with things like AutoSAR and other standards that are coming up for similar concepts. Integrations with CATIA, MATLAB. So we have in the mechanical world currently have integration with the ARIS tool, bill of materials tool there. We're in discussions with the other mechanical PLM tools and CAD tools organizations. That piece of the process, this PLE, product line engineering world, really started as a pure software discipline, emerged into a systems and software discipline, and now, in the last year or two, we've been successful in starting our move into the mechanical world as well. So I'll just say things like the CATIA, PLM tools, Siemens, Dassault, PTC, those things are all on the horizon. You'll hear a lot more about that in the upcoming months for sure. MATLAB, we do have an integration there that uses the interfaces around MATLAB. We don't have a deep integration such as the one that I'll show you with Magic Draw coming up here shortly. Looking at a couple of other questions here before we jump into the demo. Yeah, so I think, looking for an example of a domain concept and a characteristic in the product domain, we're going to have a really nice example from the automotive domain that will start to make it really clear what it is when we talk about feature models. So hold on for 2 minutes, and we will have that to show here shortly. Okay, there's a question about the relationship between requirements, designs, code, and test. So requirements from discipline. I think, yeah, this sort of gets into the definition of what is requirements, what is designs, how does that relate to code and test. I think there are absolutely requirements that get decomposed from high-level customer-facing requirements down into subsystem requirements, down into software component requirements, for example. So all of those things are absolutely candidate for introducing variations and variation points. And so we have customers that fully support requirements decomposition with variation points under this paradigm that I'm describing so far. So as we go into the demo, I know we're going really fast here. Just if you're looking for more information, I got a couple of email addresses up there. We'll be glad to have further, we can do one-on-one WebExes and conversations. So please feel free to reach out to further discuss any of these questions that are coming up. So here, just as a reminder, as we go into the demo, we're going to focus on, what are features, what are feature catalogs. We've got bill of features, how to define a particular product configuration based on the unique feature characteristics that are selected on that product. How do we relate that? And we'll look specifically at the relationship between feature models and our Magic Draw models. And then how do you push a button to go from a superset view of, for example, a model out to a subset view of the model as being filtered for product A, product B, and product N. So just sort of keep this visual in mind as we go into our demo. So here is the main interface to the Gears product. This is the BigLever product that's managing feature models and bill of features catalogs. You can see along the left-hand browser view here, you can see a lot of those concepts shown in the graphic that we just moved from. So here are features, here are feature profiles towards the center. Those are our bill of features choices. Down at the bottom we have a set of assets that are being configured in the factory. In this example we have about 10, but we're going to focus on our magic draw models here, one particular asset for this demo to show really highlight this nice work that we're doing with No Magic. So in the upper right, let me blow up this view to show you a detailed view of a low-level feature model for a particular subsystem. And as you glance across here, you might get the sense of what this is. This is a power door lock system on an automobile. So all of the different ways that, for example, an automotive manufacturer could support locking and unlocking the passenger compartment, the luggage compartment, the fuel filler door compartment, and so forth. So in this example, we'll just look at a couple of features within this feature model. The first thing you'll notice in this type of model, this feature model, it's a tree structured model. And think of it as a decision tree. In order to configure a particular product, I need to walk across this tree and make choices about what's in and what's out. So we'll look at a couple of features here really quickly. Lockout deterrent feature in the upper left is an optional feature. Boolean feature means it's in or it's out. And I have a checkbox. I can check it if I want lockout deterrent in my locking system. I'll uncheck that box if I don't need it. So this is the capability that prevents you from locking your keys in the car. There's proximity sensors, there's alarms, there's software, probably some extra wiring. There's a chip in my key fob so I can detect where my key is at. All of those things come with a cost, and so we've made that an optional feature. If we want to incur the cost of adding this to a vehicle, we will. On our less expensive vehicles, we'll just not include that particular capability. Lock status indication, the next feature over here, is type enumeration. And so this choice is pick one from a list, right? So there's 3 ways that we're providing the ability to visually determine, is my car currently locked or not? There's the old school physical key stem that goes up and down on my door sill. I can look there and I can see and I can make sure my door is locked or unlocked. LED is another approach, so a little LED light might be sitting there on my door sill and it goes red when my car is locked. It goes off when my car is unlocked. A screen icon, if you have a nice console screen, might be another way to glance and be able to determine, is my car door locked or unlocked? So I have to pick one. I can't pick 0. I can't pick 2 or 3. Enumeration means pick one and only one. And then finally, request source is a set type feature decision. Here I have a list of children, sort of like my enumeration, but here I can pick 0 or 1 or 2 or all or any combination of the features within this particular list. And so checkboxes now indicate it's a multiple select capability. And so the choices here determine what are the different ways that I can electronically request that my doors are locked or unlocked from all different sources of that request. So key cylinder on the outside, remote control key fob button, automatic locking and unlocking, so when I drive off, get up to 7 miles per hour, for example, maybe my car will automatically lock based on the speed of my vehicle. You can see features here. Decisions can be multi-level, so if I make one decision, then I need to go to the next level of sub-decision underneath that particular feature. All right, so these are available choices. This defines the space of available options. My profiles over here then represent that bill of features, that different configurations, a collection of decisions that together represent a profile or a bill of features. So you can see here we've created 10 different profiles, and if I click through the list, you can see that what's different in the upper right-hand corner are simply the set of choices I've made based on that feature model that we showed you initially. So as we go through the list, you can even see the names of the profiles go from basic, intermediate, up to premium. So as we go higher and higher in this list, it's more and more bells and whistles and more expensive, ultimately, implementations that we've got here. So what I'm going to do now is use this. Remember, we feed these feature profiles into the top of our factory, and we're going to filter and configure our no magic models about entry control systems, and they'll be configured according to the feature choices we've shown here in our feature model. So I'm going to build two of these. I'll build our basic configuration. So here we're going to pick our basic profile. I'll disable a lot of the assets. We're just going to do a source code generation and a magic draw generation in our factory. And so I push the button and the factory runs. When it's done, we get a report, comes out on the bottom. That all looks good, no errors. And so again, two things just came out the end of our factory, a collection of source code that I'm going to run through a simulator. And so the configured source code, when we simulate it, will allow you to see, what is in this configuration. This was our base configuration, very simple key stem, the old style mechanical locking and unlocking. Our key has no remote control capabilities. It's just a mechanical key, so I can lock and unlock my vehicle with the key cylinder. When it's open, I can open and close the door. If I'm on the inside and I lock it with the key stem, then my door is locked, and if I try to open it from the outside, it won't open. So this is a very, again, simple, old school, very mechanical approach to my door locks. So let's look at our magic draw models that represent the superset models that come into the factory, and then we'll look at the subset models that got produced as part of that actuation process. So I've got two models here. I have a class block diagram model and a behavioral model through an activity diagram. So we'll start with our block diagrams here, our class model. So across the top, we have a series of controllers. And so things, all of the various controllers that might be needed for locking and unlocking the vehicle. We have a network bus in the middle, and then down across the bottom, a series of actuators and sensors for doing the locking and unlocking and the visualization of that system. So for any of these model elements where you see a gear icon on the upper left-hand corner, this is a variation point. And variation points, again, are these things that behave according to the feature choices in our feature profiles. So some of these variation points you can see have red slashes across them. When we ran our factory, the factory determined, what's in, what's out. Do we need these variation points to be part of the model for this configuration or not? So the for example, our key cylinder sensor in the lower left-hand corner, we're using a mechanical external key cylinder for locking and unlocking. That model element is here. It doesn't have a red slash through it. If I click on that, you can see in the left-hand corner, lower left browser window here, there's a piece of logic. This is the logic that gets executed inside of the PLE factory to say, do I need this model element or not? And it says here, if our request source feature, that set that I showed you, if that includes a checkbox on the key cylinder subcomponent, then we want this model element to be in. otherwise not. And so that, of course, is why it's in here. We had that selected. Whereas the sensor next to it, the key fob, that's our remote control. There was no remote control capability in our key fob, and therefore this has a red slash through it saying we don't need it. If we look at the behavioral model, we can come over here into an activity diagram. Same kind of thing. We have activities, and we have actions, and we have transitions, control flows. Some of these are marked as variation points, some are common, and you can see the ones that are in and the ones that are out based on the last run through the factory. Now this view helps me visualize and debug what's going on. I can also take a view where it's called the staging area view, where I can look at only what's left. I'll filter out those things that were marked for omission, and now we're left with a clean model. So we're doing some really nice work with Magic to do this model transitive projection that removes all of the unneeded, unnecessary content. And so here you can see is our activity diagram and our class diagram with all of those omitted elements removed from the model. So now here's my basic model that includes only the content that's appropriate there. So very quickly, let's just run this one more time for our premium product. I'll go back here to the factory. We will select our premium plus product, all the bells and whistles. Here we go. I'm going to regenerate our source code for the simulator, and I will regenerate our magic draw models. So here is the simulator so that we can visualize what it is that is supported on this locking system. So here we have a fully electronic key fob, no physical key stem at all. We have no key cylinder because we don't have a physical key. So this door handle doesn't have a key cylinder at all. The locking and unlocking, we're using an LED, and so you can see our electronic courtesy switch inside of the vehicle. For example, we can lock and unlock the vehicle from there. We can, our vehicle's unlocked, we get in, we start the engine, and we put the car in out of park. The doors automatically lock. That's how we've got the choices made to configure our automatic locking and unlocking based on the gear or the speed. So that's part of our system here as well. So if we go back now and say, well, what happened in our magic draw models? The factory went in and recolorized our models in terms of what's in and what's out. So in this case, now key cylinder sensor, we didn't have a key at all, didn't have a key cylinder. That particular sensor is marked out, but we have a key fob sensor, our digital keypad is in, exterior lock sensor, all of our controllers, because we've got all of the bells and whistles enabled, all of those controllers are included in this particular build of the system. And in our activity diagram, we've got lockout deterrent, and so now we're going down that path, whereas previously we were bypassing that when that feature was disabled. And we've got some other transitions that are marked out here because we're not bypassing, for example, the display status. We have a real electronic display now. If I go into our filtered models, those, again, the extraneous content is removed. Here's the final clean model with exactly our premium configuration of controllers, actuators, and sensors. And our activity diagram, again, here's the clean activity diagram that matches exactly the features that we requested within our feature model. Okay, so that takes us close to the top of the hour. Didn't leave us a huge amount of time for questions. Sorry about the kind of running it up to the end here, but we did get to answer a few questions along the way. So let me see if I can get to a couple of others, and then maybe my friends at Magic Draw here, are there other things that you might want to do to wrap up the session today?
Thank you, Charles. So you can go through the questions if you think that it's some questions which can be answered today, but all those questions will be covered in the web page, and the answers will be provided together with a recording of this webinar at www.nomagic.com MBSE webinars. So we could wrap up actually, and then you will find your answers, the answers to your questions in about a week period.
Great. Okay, well, thanks again to everybody for attending today. We'll be glad to do any follow-ups. Feel free to reach out. Because of the partnership, if you want to reach out to Magic or BigLever, either way is fine. We'll make sure all of the dots get connected, and we'll help you explore how this particular solution might be able to help you deliver your product lines in a much more efficient and effective sort of way. I'd love to have that conversation.
Thank you.
So thanks again.
And thank you, Charles, for a very good presentation. This was the first time we are presenting this integration between BigLever gears and Magic, and definitely we will have more presentations in the future. We are looking forward for that, maybe specifically for some domains, some vertical domains, with the details and best practices, how to do stuff and to achieve the value from this integration, because the devil is in the details, and we are looking forward to make this integration working in the right way, and this is our goal. And that concludes our first webinar this year, and this is the first webinar from the series dedicated for our partnerships. And last year we had a very big success with the webinars dedicated for MBSE, and we are continuing those webinars also, and that will make us to produce 2 webinars per month this year. One series of webinars will be dedicated for our communication, collaboration with the partners and the best organizations around the world, like BigLever, the best experts working in this area. And we still will continue with MBSE webinars and all those new practice experience. And we will invite the best standards, technology, and methodology experts into our webinars. So thank you, Charlie, one more time. Thank you, Thomas. Thank you, Andrew, for participating in the webinar. And that's all for today, guys.
All right. Thanks.